Hi, chemistry students. Hopefully you have been able to find everything that you need. So please make sure you have out a pencil, a notebook. Grab that warm up from up front. It's a half sheet of paper. You need to tape it into your notebook at the end. Please make sure you also grab a study guide from up front. That warm up is on molarity. It's a limiting reactant problem. Today, we are going to be working on that warm-up. After that, you're going to do some stock dilutions and dilution notes, which will be in this video, and then you're going to practice at the end. By the end of class, you should be able to calculate and describe how to make a stock solution and dilution from a stock solution. Okay, chemistry students, you should have found this making stock solutions and how to make dilutions guided notes from up front. We're going to start on this making stock solutions side, and we're going to start with this upper left-hand box, which says what is a stock solution. So anytime we make a stock solution, the goal of this is to make a solution with a high concentration that is known. A solution with a high concentration that is known. What we use these stock solutions for, and I actually do this pretty often to set up our labs, is that we use them to make solutions of lesser concentrations that are known as dilutions, which we'll learn about in a minute. Right? These are used to make solutions of lesser concentrations that are known as our dilutions. So this is kind of like our why that's going to be guiding us today of like, what is the purpose of this? I'll give you a couple examples of when we would make this, and I'm actually going to show you an example of making one as well. Okay. So to go through the steps of this, we're also going to go through an example problem, which should help us. So if we just scoot this over to the right a little bit more, we have this example problem, which says we want to make 1 liter of a 5 molar nickel chloride stock solution. So we have 2 values that are given to us here. We have this 1 liter value, and we also have this 5 molar nickel chloride value. So there are 5 steps to making a stock solution that nicely go along with some lovely pictures here. So let's go through these together. Step 1 is that we're going to determine the desired concentration. Okay, so this is where we're going to look back at our problem. And what you think about, is this 5 molar your concentration, or is 1 liter your concentration? Hopefully this is an easy question to answer. And our concentration value, right, is that molarity. That's what we learned about last class. So our desired concentration here is this 5 molar value. If you need another reminder, right, this is your molarity. Units can also be written as moles per liter, okay? So we're on to step 2 now. We figured out what our desired concentration is, so let's move on. We're going to mass out, right? So on a scale, take the mass of the required amount of solute. Okay, we're gonna need to do a calculation for this. A calculation is needed. Okay, so we're gonna do this calculation right here. We have two things here. Our end goal is we are trying to get to mass, right? We're starting with volume. Our middle step is going to be moles. Okay? So, starting with this volume value, which is 1.0 liters of solution, right? We get to use our molarity value as a conversion factor, right? Where 1 liter of solution is 5.0 moles of nickel chloride. Then our final step is going moles to mass, so we're going to use a molar mass for that. 1 mole is equal to how many grams? I want you, with a neighbor, to try and figure that out, right? Grab a periodic table, calculate your molar mass. Okay, hopefully you and your neighbor came up with the value of 129.59 grams of that nickel 2 chloride, right? So multiply across the top, divide by the bottom, and we should get 647.95. We need to sig fig that number. If we look, we have two values that are given from our problem. Both of them have two sig figs. So I'm going to get two sig figs in my final answer, which means that there should be 650 grams of nickel 2 chloride. Okay, and if you look over to the left here, you see that that's how much we measured out, right? So you're gonna mass out that 650 grams of your nickel 2 chloride. And then in step 3, we get to use that. We're gonna use that nickel 2 chloride. Step 3 is where we're going to add the solute to a flask. And we're going to mix some solvent in. Our solvent is almost always water, and our goal here is just to get this to dissolve. So add your solute to the flask with some solvent, which is water, to dissolve it. Okay, so that's what we're looking at over here. We would have our solute in the bottom. You're gonna add in your water, right, to get that dissolved. In step 4, we're gonna add solvent to the flask until our desired volume is reached. Now, the reason that we don't do this with step 3 is that you need to sometimes swirl that flask, really mix it well, and it's really hard if your flask is full to get that good swirling motion in and get everything dissolved well, right? So a lot of times we fill this like halfway and then we dilute at the end. Now, the last thing that we're gonna do, right, when you do this, you're gonna have a really concentrated bottom section, right? And then the top part's gonna be less concentrated, where you have a lot of water, right? And you're gonna fill it all the way to this line. So our last step is that we need to mix our solution until it is homogeneous or uniform. So we're gonna go for a uniform mixture. Right at the end, everything should look the same, right? Our desired volume is always gonna be this little top line on this type of a flask. So it's pretty easy to measure. Now, I'm gonna show you actually an example of making a stock solution like this. So I'll show you the actual glassware we use, how I would do this, just so that you have an idea of what this would look like. Okay team, so we went through how to make a stock solution, but we're gonna actually go ahead and give this a try. So instead of wasting 650 grams of nickel 2 chloride, we're not gonna do that. We're gonna make 250 milliliters of a 0.5 molar solution of nickel 2 chloride. So we're gonna start with step 1, which would be calculating how much we need of our solid, but I went ahead and did that for our new setup. So we're gonna need 16.2 grams of our nickel chloride here. So we're gonna start by massing that out after we've done that calculation. Okay, so our scale currently reads 16.20. So we have our solid now, and what we're gonna do is we're gonna take and put that into our glassware. Now, this is a new type of glassware that you're probably not familiar with. It is a volumetric flask. Now, what this is good at is this is good at measuring a specific volume, right? So this is only good at measuring 250 milliliters. If you wanted to measure something else, it's not gonna be your best option. So now we're gonna add in some water. I'm gonna make a mess. Right, so that we can dissolve our solid. Now, to dissolve our solid, we're gonna use something special. This is a magnetic stir rod. So we're gonna go ahead and add that in, and we can use a hot plate to use the stir function. So that's gonna stir our solution for us. We're gonna need some more water. It's gonna stir our solution, and we want that to go until it's fully dissolved. So it's gonna stir for a little bit. You see we have this nice green color in our stock solution. Once everything is fully dissolved, which we're not quite there yet, once everything is fully dissolved, we're gonna remove that magnetic stir rod, and we're gonna fill our water to this top line, right? That is exactly 250 milliliters. Okay, looks pretty good. So we're gonna turn this stir rod off, and how we take this out is also with a magnet. Now we have to pull our stir rod out because that takes up volume in there, right? So now we want to fill this up to the line with water. Okay, once we get to this top section, we're gonna get close to our line and then stop pouring. And then we're gonna finish it off at eye level with our little squirter bottle. Okay, now you can see at the top of this looks very not green, right? So we have a little lid that we put on this. We want to make sure that this mixture actually gets mixed. So what we do is we invert our volumetric flask a few times so that we get a nice uniform green solution. Okay, so now we're going to talk about how we can actually use the stock solution to make something that we call a dilution, and you'll be making a dilution series next week. Okay, so now we've had that lovely demonstration of how we actually make a stock solution. So let's talk about the actual use of this, right? We said on the front of this that we use these stock solutions to make lesser concentrations, or our dilutions. You're actually going to be making your own dilution series next week as we do a lab. But the key here is that a dilution is more dilute than your stock, right? We're going for a lesser concentration. So let's do this. What is a dilution? Pretty straightforward. A dilution is a solution with a lower concentration. Pretty crazy. So we have a solution with a lower concentration. Okay, now how we actually make this dilution is by adding more solvent, such as water, to a solution with a higher concentration, which is our stock solution. This is made by adding solvent which is water, oftentimes. We will talk about some non-water solvents, but we won't get to use them in here. To a solution with a higher concentration. Which is your stock solution. Okay. Now, here's the thing. You cannot make a more concentrated dilution, right? Diluting means less concentration. You'd have to make a new stock solution if you wanted to go to a higher concentration, because you can't add water to make something more dilute. So we're going to do another example problem as we work through this, and our example is this. How much of a 5 molar nickel 2 chloride stock solution is needed to make 0.75 liters of a 1.25 molar nickel 2 chloride dilute solution? Okay, here's where we're going to start. We have 3 values given in our problem. Step 1 is you want to identify your knowns and unknowns, which you should only have one of, right? Okay, here is the equation that we're going to be using so that we can identify this well. Your equation is M1 times V1 equals M2 times V2. Now, here's what these things stand for. Whatever your ones are, we're going to say that this is our stock solution. Right? Molarity, volume. Our 2's then are going to be our diluted solution. It doesn't actually matter if your stock solutions first and your diluted solution second, the thing that's really important is that your two values for the diluted solution are multiplied together, and your two values for the stock solution are multiplied together. If you mix those up, you won't get a right thing. Okay, so knowing this, we're going to come back to this problem up top. We have three values, and we need to identify which one's which and what we're looking for here. So we want to know how much of a 5 molar nickel 2 chloride stock solution is needed. This is my stock solution. This is a molarity, so this is my M1. Is needed to make 0.75 liters of a 1.25 molar nickel 2 chloride dilute solution. This is my M2. This is the volume that goes with that, which means what I'm missing, what I'm looking for, is my V1. That's my question. It's my question mark, okay? It's my unknown. So let's go on to step 2, right? I diagrammed my problem. I know my equation. Here we go. We're going to calculate the unknown. There's an important note here. You need to check your units. You're going to have many problems today where volumes are given in milliliters. If both volumes are given in milliliters, that's fine. You do not need to change them into liters. You just need to make sure that they're both milliliters. Or if you're finding a volume and the other one's in milliliters, that final volume should also be in milliliters. So be thoughtful about where your units are canceling out. Okay, as a reminder, if you need it, right, your M here equals molarity. Your V is equal to volume. So you should have units of volume or molarity on your final answer. Okay, we have two options when we solve a problem like this. You can first rearrange your variables so that you know exactly what you need to do, or you can first plug in numbers and then rearrange to solve. It doesn't matter. It is up to you. I'm going to show how you would rearrange your variables in this video, but if you would like to do it the other way, that's totally okay with me. Okay, if we're trying to get V1 by itself, right, that's our unknown, we would need to get that by dividing both sides by this M1, right? And that would leave us with the equation V1 is equal to M2 times V2 over M1. So we can plug in and see what we have as an answer. So we're going to take that 1.25 molar, multiply it by 0.75 liters. We're going to divide that whole thing by 5 molar. Your molarities are going to cancel out here, so your final unit should be in liters. And if we plug that into a calculator, we get 0.1875. We got to sig fig this. 2 sig figs, 2 sig figs, 3 sig figs. Keep the lesser amount, which is 2. And we find that V1 is equal to 0.19 liters. Okay, we solved for our unknown. Exciting. Okay, this leads us to step 3. We're going to measure out the volume of stock solution. Okay, so what that would look like over here, right, is that you're going to pour in however much stock solution you need. So you're more concentrated. That would be 0.19 liters, which is 190 milliliters. Okay, then our next step is that we're going to dilute with deionized water until desired volume is reached. Dilute with deionized water, sometimes called DI, until desired volume is reached. Right? So over here, we would have our concentrated, right? But we're adding water in, so it is getting lighter by the moment. And then in step 5, we're just going to mix this once again until we get a uniform diluted solution. Okay, hopefully we feel pretty okay with this, right? This is our new equation that we've learned today. It is on your equation sheet. The other stuff, right, this is just continuing with those mole conversions that we learned about last time using molarity, okay? So you have a homework sheet up front that you should grab. It says stock solution and dilutions on the top. If you're curious what that looks like, it looks like this, right? A lot of the questions on the first page are all like concepts, right? Such as something like this. You have a couple calculation questions in the first part, and then 5 through 10 are all based on that dilution section, right? There's an answer key at the end for 5 through 10, so you can check your work. I will be checking this off next class, and we'll be going over this homework as well as that molarity homework, so please be ready for that. Can't wait to be back with you all. I hope you have a wonderful weekend, and I will see you on Monday. Bye, team.